So now it's the time to build a formal model, by which I mean the interesting part of this presentation is over. We are now moving on the relatively boring part. So what the agent's problem is she observes a stochastic process. She chooses a stopping rule, which is a stopping time, and a terminal decision as before. And she's maximizing some utility function, which is the utility at the terminal, I mean, at the time she stops, subtract by the price. So similarly, we have the principal's problem. The principal observes nothing, but she chooses a mechanism. So a mechanism here is an allocation plus a price. Usually it's allocations, but here you can just think of the allocation as the stopping rule. So basically, the principal is helping the agent to choose a stopping rule by using different prices at different time for different allocations. So the principal is maximizing something, but it doesn't really matter here. So some of the important functions are the stopping value, which is the utility you get, the maximum utility you get after you stop, if you stop at time t, and the continuation value is at time t, if you continue for at least one period, what's the optimal utility that you will get when you stop in any kind of future period in expectation. And the value function as usually is the max of these two. So diagrammatically it's like this. So on the left and on the right, the blue line representing u is larger, so we stop. In the middle, the black line is larger, so we continue. So if we repeat this, I mean, if we plot the u and v for each period, then what we have is we have the line by connecting the boundary. Then on the xt plane, we will see the upper thresholds and lower thresholds that we saw at the beginning of this presentation. So one very intuitive way of implementing something would be like this. When I increase or decrease the price, I will just shift this ut up and down, right? Because price is quasi-linear here. So if I increase the price, I will just shift the blue line, the blue curves up. So for example, if we want to implement this open one, we will just shift the one on the back more, and I would shift up the one at time closer to 0 and shift down the u when t is large. And similarly, if we want to implement something like this, we could do the same. And also, if we want to implement something strange, like this, it's okay as well. But one problem that you find immediately is it's not easy to implement the strange one, because we have asymmetry here. So that would be one problem. The other more important problem is, why do they actually shape like this? What condition do we need on U such that they actually shape like this? So to answer that question is very complicated. So we will start with something simple. So we will start with the single cutoff rule first, and then we'll move back to this binary ones.